All right, hello everyone. It's Friday, so once again, time to do studio review for the week. This week, we're on Studio 2. We've got two different problems for you this week. Gambler's Ruin is the first problem we'll look at, and then we're going to compute pi for the second part of the studio. Going to go ahead and jump right into the first problem. I think it's important to kind of understand what we're doing here. We're gonna do a simulation. So we're going to simulate the idea that we're going to be going down to the casino with some amount of money, and then we're going to play a game, and if we win, we get $1, and if we lose, we get $1, or we lose $1. And so then, if we end up winning enough, we eventually decide to keep our winnings and go home, call it a day. Otherwise, we'll keep playing until we lose everything, and at that point, we have no other choice but to go home. So those are the two possible outcomes. We're either going to hit our preset win limit or play until we run out of money. And so this is our job. We want to do this professionally. We want to know some days we'll win, some days we'll lose, but we need to figure out what's a good win limit. When should we stop? What's a good number to stop at? How often should I expect to lose? How often should I be losing on average? What's the normal bumps that I should be expecting along the way? So we're going to try and answer this question a couple different ways. The first way is we're actually going to simulate this. So we'll actually use the computer to play the game for us and tell us whether we won or lost. And then we'll also use the computer to do some math, some perhaps more complicated arithmetic, to compute what the expected value is. Of course, real casino games usually involve chance, some degree of randomness involved. So it's not necessarily that we're going to hit the expected value all the time, but we still would like to be able to reasonably approximate what we can expect to see during the simulations. So let's go ahead and hop right in. Going to go ahead and follow the instructions which tell us to open up Eclipse, load in the repository, which I've already done, and we're going to create a new class. I'm going to call this Gambler's Ruin. Doesn't really matter, I suppose, what you call it too much. Whoops, I forgot to put in the public static void main. So I'll just type it real quick. Okay. Real briefly, before I begin, I feel like I should give Franklin a chance to say hello. Hello, Franklin. He's here with me, as he usually is during these review sessions. All right. The next thing that it tells us to do is we're going to accept the following inputs. So that's going to be using the scanner to read in those inputs. So I know how to do this because I'm very familiar with using the scanner. If you needed to go back and look up how to do it from a past assignment or past studio or something like that, that's totally okay. That's totally expected. But you can also watch what I'm doing here if you want to kind of see for yourself how you might set this up in your own code. We need to accept start amount, the amount of money that we start with. So we're only ever winning or losing $1. I think integers are okay then for this purpose. I saw some people using doubles, which is not necessarily a problem either, but I think integers kind of keep it a little bit cleaner, a little simpler. So I'm going to use integers. Really doesn't matter though. And I should probably put a prompt here, huh? There we go. The other values that we want are the win chance, so that's going to be a probability. That's a number between 0 and 1. So that's definitely going to be a double. Let's go ahead and do that next. Forgot how to type all of a sudden. There we go. So that'll ask the user to type in the win chance, and then the scanner will read it in. And then finally, we've got the win limit. So this is how much, what our upper bound is. And because start amount is an int, we only ever go up or down. I think this can also be an int. And I'll just copy and paste this line here real quick. All right, there we go. we've gone ahead and set up the code to put together or to request the inputs from our users. But we need to do something with those. So the first thing that we want to do is simulate a single day. We want to write code that will repeatedly play until we hit our win limit or until we hit 0. Okay? We're going to include print statements to show every time we win or lose. I think we can even start one step farther back than that if we want to. Instead of simulating an entire day, let's just simulate one play of the game, right? So I want to simulate one play of this game. We're basically, so if the win chance, in this case, the way to think about it, if the win chance is 0.5, 50%, then we're flipping a coin. Heads I win, tails you lose, or tails I lose, rather. So we need to generate some random value and check to see if it is where it is in relationship to this win chance. So in order to generate a random value, we'll go ahead and did I win? Go ahead and use math.random here. So if the win chance is 60%, right, or 75%, that means I want to win 75% of the time. So if this value, which is between 0 and 1, is less than that, then that should have the effect of simulating the case that I am winning roughly 75% of the time. I would expect it to be above that, the other 25% of the time. The way that we can do that check, so we have a question now, right? Is this value less than this value? And the way that we perform such checks in our code is using something called an if statement. So if the did I win is less than the win chance, we want to indicate that we have in fact won. So I'll go ahead and just say system.out.println here, win. If this is greater than the win chance, that means that we have lost. So there's another choice here, right? Either I'm going to win or I'm going to lose. That's always going to be the case. There's always going to be one of these two possible outcomes. And the way to represent that is by including this else statement. So the else statement is optional, right? Without the else statement, I have a piece of code here, that is either going to happen or not happen, depending on the condition. By including an else statement down here, we now have the case where if this is true, the Boolean expression evaluates to be true, I do this. If this is going to be evaluated to be false, then I jump down here and I do whatever this other thing is. So I can come down here and say lose. Okay? And I think really this should be enough for us to go ahead and get started simulating one particular play of the game. So I haven't actually done anything with the start amount or the win amount yet, so it doesn't really matter what I enter in here. But if I enter in 0.5 for the win chance, the win amount doesn't really matter again. And it flipped the coin and said that I lost. Okay, but if I ran it again, I would expect roughly 50% chance that I would win, right? So let me go ahead and think about if I did want to run this a whole bunch of times. There's a few different ways you could do it, right? You could turn these off so that they don't have to prompt you every single time. But really, I want this to be able to repeat. That's the ultimate goal. I want to pick a new random number and then check to see if I won or lost every single time. So in order to perform repetition, we need to have some sort of a loop here, some sort of a loop. And once we've identified the fact that we are doing repetition, we need a loop. We've got a choice to make. We either need to choose a while loop or a for loop. And so to help you to make this decision, well, first I think you should know that in the vast majority of cases, which version you choose actually doesn't really matter. I think you can probably get it to work with both. So you should probably choose the one that you feel the most comfortable with. However, that being said, there are some situations in which a certain type of loop definitely lends itself to the problem a bit better, even though it may be possible to use the other kind of loop. There's one choice that is very clearly going to lead to a cleaner solution, an easier, simpler solution. And this is one of those situations, in fact. I think that this situation strongly calls for a while loop. And to understand why I say that, consider that because of the randomness here especially, we do not know exactly how many repetitions it's going to take for us to either, hit our win amount or lose all of our money. It could happen very quickly. It could take a very long time. I mean, in theory, right, it's possible that it could even take an infinite amount of time if the random numbers came out just right. Extremely unlikely for that to happen, but the number of repetitions is unknown. For loops are really good if you know how many repetitions you need to make. So whether that be an exact amount, I want 10 repetitions, or whether that's, I want to repeat for every letter in this word, or something along those lines, right? If you have a very clearly defined number of repetitions, that's a good time to use a for loop. In any other situation where you can't definitively say how many repetitions it's going to take to get to the goal, a while loop is going to be a better fit. So the question then is to say, all right, well, what's the condition actually in this case? It's related to how much money we've got. But before we talk about that question, I could actually take a moment to just sort of play around with what we've already got here and show you. Whoops, that should be indented as well. The while loop just takes a true or false statement here. I can actually just put the word true in here, and that means that this while loop is going to run forever, which is usually not what we want. But I just want to see, is if my random numbers are working appropriately. I want to see if the game is being simulated appropriately. So letting this just sit here and spin for a while, I'm not too worried about that for starters. Let's just go ahead and run this, and I'll enter some values here for the start amount. I'm going to enter a win chance of 50%, so I would expect to see, roughly 50% wins, 50% losses, and the win amount doesn't matter. And here we go. It's just spitting out now because of this while loop here, while true. It's just going to keep spitting this out until I'm done, until I decide that I'm finished. And, if you ever run into that situation, you can stop it by clicking the red square down here to return control. And so now the question is, am I seeing roughly 50% wins and losses? Wow, look at that streak right there. Holy moly. Am I seeing roughly 50% wins and losses? I mean, seeing streaks like that is to be expected, right? Even with the randomness involved, you're going to have streaks sometimes, and there's going to be long streaks of wins and losses that appear. I think, though, that this very clearly, to me, obviously I'm not sitting here and counting them all, but looks roughly 50-50. And if we want to try to see the difference, we can enter a more skewed value. Let's say I want to win a large amount of the time. So I'll enter in a big win chance like 90%. I should see very few losses now, right? And so you can see that if I let it run for a little bit, the difference here is, I think, pretty distinct. You can see that I still do lose periodically, but the number of losses is much reduced. So I'm pretty confident that this code is working the way that I want it to, in terms of checking to see whether I win or lose. But now we actually need to take the winnings and losses into account by affecting how much money we have. So here it tells us that this is how much money we start with, and then there's how much money that we want to stop if we reach, and we need to replace this condition with something that reflects the fact that we've run out of money or hit the appropriate amount of money. So instead of saying while true, I could say something like while start amount is greater than 0. So keep playing until I lose everything. And in order to make sure that this is going to work properly, I think it's important to note that this value is going to have to change, right? And right now, I'm not actually changing it anywhere. I need to, reflect the fact that I win $1 if I win, and I lose $1 if I lose. So let's add $1 if we win, subtract $1 if we lose. Go ahead and run this again now. Now our starting amount matters, so 10, win chance is 50-50, win amount is 100, okay? Here we go. We can see lose, 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 win, 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 lose, 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 lose. All right, it actually stopped this time. It's no longer running. I lost all my money. My money is gone, right? My money is all gone. In fact, if I wanted to, I could, put a statement down here to that effect. If start amount is equal to 0, ruin. So at the end of the day, I want to print out whether I ruined. Otherwise, win. Success. I don't want it to say win because it already says win up here, so I want it to say something a little bit different. We can say success. Okay. Let's try this perhaps a few more times now. Start amount of 10. 50-50, $100 is when I'll go home, and I lose, lose, lose. I win, lose. It took a lot longer this time. You'll see I was there for a lot longer. It took me a lot more plays, right? But eventually I did, in fact, lose all of my money, and down here at the very bottom it says ruin. And I'm going to ask you to take my word for it, but I think that no matter what I try to do with the program as currently written, it's always going to tell me that I've ended in ruin, because the way that this condition is stated, I'm going to keep playing as long as the start amount is greater than 0, which means I'm not going to go home until I've lost all my money. And any professional gambler will tell you that that's not really a great way to make money at the casinos, right? You have to go home with more money in your pocket than what you started with. So you have to pick a limit upon which you decide to go home, and that's not reflected here in the condition. I want to keep playing, while I haven't gone broke. But I also want to keep playing while I haven't hit my win amount yet. So the condition isn't just based on this, it's based on more than one thing. And we can incorporate that by bringing in a compound operator here, the AND operator, while the start amount is less than the win amount. Okay, now we're going to actually stop when we hit our goal. So now if we actually try this out, we can see start amount of 10, 50, 50. Let's do a win amount of 20, I guess. All right, cool. Lots of winning, some losing, and then we hit a success. And, I hope that you tried this a few times to see. Oh, that time I ended up in ruin. Okay. So we now have a program, I'm arguing, that tells us whether we're going to win or lose for one day. I want you to remember that this is 1 day's worth of playing at the casino. We've got a whole bunch of wins and losses set our record, and then we just go home whenever we run out of money or win a whole bunch of money. Okay. So we've already, I think, checked a whole bunch of these. Let's see. The next part of the studio asks us to simulate a certain number of days. So this is 1 day, right? This is 1 day's worth. Actually, everything that I see here is 1 day's worth of work. And at the end of that day, I'm going to go home, and the next day, I'm going to wake up. I'm going to go back down to the casino with the same starting amount, right? And I'm going to, and the same win chance, and I'm going to start the whole process over again. So we're going to ask now for a number of days. How many days in a row do I want to actually simulate going down to the casino? And we'll go ahead and grab that in from the scanner. And this is an example of a repetition where we know the number of repetitions that we want. We may not know what this exact number is, but we know that I want to repeat, once for each of these days, right? We have a value that represents the number of repetitions that we want. So in this particular case, writing a for loop is very straightforward. There's 3 parts to a for loop, so we have to initialize our loop variable. That's the first part. Typically, we name that loop variable I in a lot of cases, although it doesn't have to be named I, but that's a very common loop variable name. Then we have to specify when we want the loop variable to, or when we want the loop to end, or to keep going, right? The condition, much like the condition for a while loop. Here, we want it to go while I is less than the number of days. And then finally we have an update condition. What's going to happen to our loop variable at the end of every trip through the loop? So the way that this is going to work, if there are 3 days, right, I is going to take on the value 0, 1, and 2. If there are 5 days, this I would take on the value of 0, 1, 2, 3, and 4, right? It might seem a little odd that I'm starting from 0 instead of 1. If you want to write the loop starting from 1 instead of 0, you could. That would change, you know, a little bit about what needs to happen, but it would still work. It would still perfectly work that way. However, as computer scientists, we kind of get used to starting to count from 0. It's a very common thing that you're going to see, especially starting next week as well. You'll see it happen very frequently. And so this is the loop that we can use to repeat our trips to the casino. But remember, our trips to the casino we've identified as being this entire block. So really, I need to take all of that code and put it inside of the for loop that I just wrote. And I'm actually, you'll notice I'm being very careful with my indentations to make sure that I'm moving things over, keeping my code very clean and organized so that I can tell exactly where things are inside of my program, where the if statements are, where the while loops are. We can see that I've now entered a situation where I'm in a nested loop. So I've got a for loop and then a while loop inside of that for loop. This one takes care of the days, and then this one takes care of playing the game down at the casino, right? So this is great. Let's try it out. Let's see what happens if I go ahead and do this. I'm going to go ahead and the start amount is 10. The win chance will be 50-50. The win amount will be 20. And the number of days I want to be, you know, like a good number, like 100 days. Okay, wow. It's over. We did it. And here I see win, 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 lose. All right, so it's playing the game. I see those print statements. And then I get down to the bottom and it says success. That's good. So I had a successful day at the casino after I won a bunch of money, but then I don't see any more wins and losses taking place after that. So it just tells me on the very next day, it says success, success, success. And actually, if we wanted to, now that we have this for loop, we could include a little bit more information here, right? Down here, before we print out the ruin or success, I could come down here and say day plus I. So I is our loop variable. That's what's going to be counting up, 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 up. I'm going to put a space in between, so it's just a little easier for us to read. Let's try this again. See if we can notice. 50-50, 20 for the win amount, and 100 days. And oh, wow, okay. Win, win, lose, 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 lose. All right, so the first day, day 0, we hit success, and then it's just successes. So that doesn't seem right. You would expect to see some days are going to end in ruin, some days are going to end in success. There's something that's not quite right here. So let's try to figure out where the code doesn't match up with what our simulation is expecting. We want to go to the casino. We want to play until we lose everything or until we win, hit our win amount. We end the day in success or ruin. We go home and then we start the process over again. We go back down to the casino with the same starting amount that we did the day before, and we repeat. And I think that's where the problem is coming in, right? Consider that I'm going down for the first day, everything's working great. I check to see, and then I'm not ever telling it to go back to the original amount. Go back to the casino with the original amount before I go to the casino again. So if I come home with success, it means I got a bunch of money. I go back to the casino and it thinks that I already won a bunch of money, but that's actually the money that I had from the day before. So it just tells me that I already did really well, and I go home when actually I haven't done anything. So we need to actually introduce another variable here. So this variable is called start amount, which is a good name for that variable, but not really for the way that we've used it. I'm going to make a new variable into like current amount, right? And actually, I put this in the wrong place. Because I need to set this at the beginning of every single day, I can actually do this inside of my for loop, right? And now, instead of manipulating the start amount, I'll just manipulate the current amount. which is important because at the beginning of the day, I need to reset it to the original start amount. So if I was changing the start amount, oh, I need to change these as well, don't I? I wouldn't be able to do this. I wouldn't be able to reset this properly anyhow. But now with that done, we can try this again. And see, the start amount will be 10. The win chance will be 50-50. The win amount 20. The number of days will be 100. And boom, there we go. Day 99 is a success. I can see it's actually playing games. Day 98 ended in ruin, right? Day 97 ended in success, ruin. All right, now I think we're at the point where we can probably take these messages out. Right? I'm pretty satisfied with the wins and losses that are showing up. I want to see those success and ruin values. So beautiful. There we go. And you can see that we now have an idea of how many days we would expect to win and how many days we would expect to lose, correct? And if we wanted to, we could even keep track of that. In fact, that might be what the instructions... So I'm printing the simulation number, the number of plays that took place that day. All right, cool. So that's not a value that I'm currently checking, but certainly one that I could be checking. I think it's going to require another variable to be introduced. At the beginning of the day, the number of plays is going to be 0. So, and then every time I go through this loop, that's going to be 1 play. So I'll say numPlays plus plus. And then down here, I can print out the number of plays. Like so. And it'll tell us how many times it took us to, actually win or lose for the day. You can see that, all right, yeah, so these days I'm playing for a long time before I eventually get there, but some days it goes kind of quick. A little bit streaky, right? Such as it is. I think if you switched, the win percentage, though, you'd be able to see different things happen, right? Sorry about that. All right. We're now going to compute what we believe the ruin rate to be based on our simulation. So the number of simulations that end in ruin. So that's going to involve us counting, the number of days that end in ruin. And we'll have to print that out at the very end. So after we've done all of the days. So after all of the days have been finished, I'm going to come down here and print out days ending in ruin. I haven't made this variable yet, but I'll go back and do that in just a second. Percentage. And that would be num ruin divided by days, right? However, we got to be careful here. We want this to be a double. So I'm going to put a cast out in front, so I'm not doing integer division there. Let's go ahead and create this num ruin variable. I think it's important to note that because the ruin or success is happening within the day, and I actually have to access this value outside of the loop, we need to create this variable also outside of the loop. So we'll start it out at 0. Every time I've determined that I end a day in ruin, I will increment that value, like so. Let's go ahead and try this again and see if this has, or this is doing roughly what we would expect it to do. Days ending in ruin, 48. The percentage would be 48%. All right, I picked simple-ish numbers specifically so that I could see that it was working properly, and it looks like it is. The final part of this, problem is to compute the expected ruin and print that value out. So in order to do that, you can see we've got some math here. I've got a value called alpha, which is 1 minus the win chance over the win chance. Let's go ahead and do that first. That seems very likely to be a double. So let's go ahead and The idea is we're gonna compute the expected rate and compare that against what we actually got in our simulation. So I'm gonna do that down here at the very end of the program. Double alpha is equal to 1 minus the win rate. Wrap that in parentheses for the numerator. Over win rate. What is it? Oh, win amount is what I called it. There we go. Then we have to check to see if the win chance is 0.5, we have one computation. Otherwise, we have another computation to perform. So if win amount is 0.5, this computation says the expected ruin is 1 minus the start amount over the win limit. 1 minus the start amount. I'm sorry, say that again. Yeah, start amount over the win limit. Okay. Over win amount. We'll go ahead and print that out. And if the win amount is any other value, the computation gets a little bit more complex. We have to do powers. So in order to do that, unfortunately, exponents, we have to go to the math library. So if you type in math dot, it'll pull up a list, and you can scroll and see what values are available to you here. Here we go. We can see that. And the one I'm looking for is right here, math.pow, where it'll say a to the b value. So what we need to do is alpha to the start amount minus alpha to the win limit. All right, so it's going to be alpha to start amount minus math.pow alpha win limit all over 1 minus alpha to the win limit. Just do a little copy paste here, and I'm going to put in some parentheses just to really strictly enforce that order of operations. And I probably need to create a variable. This is quite a long line that I've got here. It mimics the equation that I'm trying to compute, right? Obviously, I didn't. If I could make this smaller, I would, but actually I can, is the thing. It might be reasonable, for example, for me to extract some of these terms out into more variables so that I can see, what reuse some of those variables instead of recomputing those values, but ultimately it's up to you as the programmer what you feel comfortable with. I'll just go ahead and print out that expected value in that case. Okay, and for this next run I'll use the values that I see here, right? Just to check to make sure that I'm doing things somewhat properly. Start amount of 2, win chance of 0.7, win limit of 10. For 500 simulations, let's give it a go. Start amount of 2, win chance of 0.7, win chance of 10 for 500 days. And we see that the number of days, so here's, we can go up and look at all of the days that ended in success and ruin, but the number of days that I had that ended, whoops, okay, so we do have a problem. The number of days that I had ending in ruin was 92, which is the percentage of 0.184, but I do have a problem here. My expected says 0, that's not good. So let's see if I can figure out what I did wrong there. It would be in the else, because the win amount is not equal to 0.5. Did I compute alpha incorrectly? I believe that's it. Look at this. Look at this. I made a mistake. Win amount is an int. So this is going to end up being an integer over an integer, and alpha is going to end up being 0 as a result. which is going to force my expected value to go down to 0. I need to cast this as a double. Or this might be a good way to do it, just putting a 0.0. There we go. That one little mistake, huh? That's all it takes. Alright, let's try this again now that I've fixed my mistake here. And see, alright, there we go. I had 108 days ending in ruin. What is this? This is the expected ruin rate. Still something off here. The expected value, am I missing some parentheses here? Yeah, their expected ruin rate is closer to what they actually got. So I've got something off here. Double check my math. Clearly I didn't do this formula right. Alpha to the start amount minus alpha to the win limit, 1 minus alpha to the win. Did I do the 1 minus? Alpha to the start amount over 1 minus alpha to the win amount. Don't see where things went wrong here. Let's see. Did I compute alpha? Oh, win chance, not win amount. Win chance. There we go. I used the wrong variable here. That would do it. Second mistake that I made on that line of code. I really did a bad job, didn't I? Well, no, that's not right. I didn't do a bad job. I'm a human, and I made mistakes, and that's part of programming, right? I don't want you all to think that making these kinds of mistakes means you did a bad job. It's a natural part of programming, and part of becoming a good programmer is accepting the fact that those mistakes happen, and then it's our job to find them and fix them. So, yeah. All right, start amount is 2. The win chance is 0.7, the win amount is 10, and the number of days is 500. There we go, that looks good. So we had 94 days ending in ruin with a simulated percentage of 0.18, and the expected value is this. So you can see that our simulation value is coming in close to, but not exactly what our expected value is, and that's to be expected because there's randomness involved. So that number is going to change a little bit. Yeah. If you wanted to continue with this example, right, the investigation would involve trying to determine, so varying the win chance and the win amounts to try and see, you know, how can I minimize the number of plays? How can I, you know, make the most amount of money with the least amount of work? Things like that. So you could use these tools to help your professional gambling career if you're into that sort of thing. I believe this is a good stopping point for this particular problem, though. Covered a lot of ground. I hope it was useful to see my solution for it. I'm going to switch and go to the second problem. Actually, the solution for this problem is pretty short. I think the most... I forgot to do my main method again. Sorry about that. I think the more difficult part of this problem is actually understanding the math behind it. So, you know, circle in a square. The idea behind this problem is that I don't need the whole spiel, I just need the image. The whole idea behind this problem is that we have a dartboard, right? And we have this circle, so I'm guaranteed to throw darts that land inside of this square. Some of those darts are going to land inside of the circle, and some of them, so they will all land inside of the square, but some of them will land inside of the circle, and some of them will not. So can we use that information to try and approximate pi? And there's a little bit of math involved. If we take into account that the area of the circle is pi r squared, right? That means that the area of the square would be, you know, the diameter squared in this particular case. If you take the ratio then of the circle to the squares, you end up seeing that the ratio between the two is actually pi over 4. And so what we can end up doing is using the number of darts to approximate the areas. So I'm going to use the number of darts landing inside of the circle to approximate the area of the circle, and the number of darts landing inside of the square to approximate the area of the square. I know I didn't show you all the algebra and the arithmetic proving to you that the ratio of the areas is pi over 4. You're welcome to work that out on your own, or come to my office hours. I'll work it out for you on my whiteboard if you would like for me to. But once we have computed that ratio of the number of darts in the circle versus the number of darts in the square, we now know that we now know pi over 4, and it's trivial to get pi from that. This is something called a Monte Carlo simulation, where we're going to use random numbers to help us perform some computation, with the idea that if we use enough of the randomness, they will converge to whatever it is that we are looking for. So in this case, if I just throw a few darts, it does not do a very good job of approximating the area of the circle and the area of the square. And I'll show you that once we get the program up and running. We really need to throw a lot of darts. We need a lot of random points before this simulation actually is effective, which is one of the potential drawbacks. But let's go ahead and get started. So the first thing that we need to take into account is, I believe, the number of darts that we wish to throw. So let me go down here and see. Simulate a random dart thrower. Yeah. Yeah, so I'm going to put in scanner and ask for the number of days, the number of darts. Oops. And here we go. Just like that. Get that imported, everything like so. And hopefully, at this point in time, you can see that once we know how many darts we want to throw, that sounds a lot like repetition, right? I need to actually generate each of these darts and quote-unquote throw them, which is really just accounting for whether they landed inside of the circle or not. So we actually need to make that happen, and that's going to require a loop. And we're back to that question of what kind of loop do we want, a for loop or a while loop. In this particular case, I think a for loop is going to work just fine. I know how many darts I want to throw. You've told me. So I'll go ahead and construct this for loop. And here, I mean, you'll see how fast that I whipped that out. That's because this is such a common structure. You'll notice it doesn't look that much different from the for loop that I wrote on the previous problem. So very similar. You're going to write lots of for loops that look like this over the course of the semester and over your programming career, for that matter. We now need to simulate throwing darts, and to help keep things simple for us, since we're going to need to use randomness, I think if we imagine the origin down in the bottom left corner as 0, 0, and then we're going to imagine this as being 0, 1. I'm sorry, that'd be 1, 0. And this would be 1, 1 in the upper right corner. So if we use math.random, since that gives us values between 0 and 1, I just need 2 values then to simulate a dart throw. One for the x coordinate between 0 and 1, and one for the y coordinate between 0 and 1. So I'm going to say, hey, give me 2 random numbers, one for the x, one for the y. That'll tell me where I fall on the square. At that point in time, I then just have to decide whether I'm inside the circle or not, right? Or whether I'm inside the or whether I'm out here outside the bounds of the circle. So let's go ahead and just do the dart throw first by generating the random values. Our x position is going to be just a call to math.random. That's pretty easy. Our y position is going to be a call to math.random as well. It's important to see math.random on here twice, right? 2 different values, one for x, one for y. We now need to figure out essentially how far we are from the center, right? So this is 0.5, 0.5. I need to compute the distance from where I am to the middle. If I'm more than the radius amount away, which we know to be 0.5, right? Then I know I'm inside of the circle. Otherwise, I'm outside of the circle. So we need a good old distance formula. So I'm going to Google that real quick. No shame in Googling the distance formula. You'll see I've Googled it plenty of times before. So one of our x-coordinates is going to be what the random one that we generated, and the other one is going to be 0.5. So you'll see I've got powers and square roots in here. All right. First, we're going to do x minus 0.5. And if I want to square that, I can use math.pow. And the distance formula then says I'm going to add the same term, but using y. Okay, and then finally, I'm going to take the square root of all of that, which we can do by using math.square root. There we go. This is going to be the distance. The distance from the center. Then we simply need to check. If the distance is greater than 0.5, I'm outside of the circle. I know that all of the darts are going to land inside of the square. That's part of the problem has been given to us. So if we're computing the ratio, right, the number of darts that land inside the square is all of them. So I really just need to count how many of them land inside the circle. So let's make a new variable for that. In circle. Start out with 0. If the distance is, we'll say if the distance is less than 0.5, then in circle is ++. All right. Once I've thrown all of the darts, I now can compute the resulting ratio, and I'm telling you that the value of pi is going to be the number of darts in the circle divided by the total number of darts, the number of darts that are in the square, times 4. And you might want to do a little bit of rearranging of this equation for the purposes of making sure that there's a double incorporated somewhere into this equation, right? Notice how I moved the 4 out front and changed it to 4.0 to make sure that this division doesn't give me problems. And I believe, unless I made some mistakes, which is certainly very possible, and perhaps even likely, that this program should hopefully do what I'm hoping it will do, which is approximate the value of pi. But let's give it a shot. All right, number of darts. So it does require, I think, a reasonable number of darts to make this happen. If I type in 10 darts, it tells me that pi is 3.2. Okay, so we're in the right ballpark, right? But I don't think 3.2 is enough to, you know, put a man on the moon or anything even close to that. So let's try it again with some more darts and see how pi changes. Oh, well, it's now 3.0. Yeah, not much better, huh? But if I try again, I get 3.28. So it is random still, right? All right, so 100 is still not quite good enough. Let's try 1,000. 3.19, that's getting pretty good. We can try 1,000 again here. 3.1. Okay, so we're getting, you know, first digit. All right, 10,000, 3.16. Let's try 100,000. 3.139. A million. The other thing that you have to keep in mind too is the more darts that I throw, the longer this takes, right? We're not really noticing the time because so far it's able to do it so fast that we haven't been able to notice how much longer it's taking as the number of darts goes up. But you can imagine that eventually we'll start to notice it. So let's see. Oops, I forgot. What was I doing? A million? Let's see how long it takes before we start to notice. Hey, there's the first time that we hit the classical, you know, 2 digits, but that's still, that digit's not right. So another order of magnitude we go to 10 million. Oh, and now actually I noticed a very brief amount of time, 3.141. We'll do 100 million next. Yep. Definitely starting to notice that, the amount of time that it's taking is getting a bit longer, but you're also noticing that the values of pi that I'm getting back are a bit better. The next one would be 1 billion. So here's what I'm going to do is I'm going to type 1 billion in here. And this is going to take, I honestly don't know how long it's going to take, but I'm going to start it running. And while it's running, I'm going to talk briefly about the homework assignment, and we'll come check on it in just a little bit. So there we go. Let that run in the background while I switch over, talk to you about assignment 2, now that we've finished the studio. Assignment 2, we're asking you to make a game called the Game of Nim. So maybe you've played this game before. It's a very simple game. You have a pile of sticks or rocks or something. It doesn't really matter what the thing is, right? And each person takes turns removing 1 or 2 of them. And then whoever takes the last stick wins the game. So we're going to design a game where you are playing against the computer. So for your moves, the human moves, you get to pick either 1 or 2. Those are the only 2 moves you're allowed to make. And for the computer, they will randomly choose. So they will randomly choose to pick either 1 or 2 sticks. There's a lot of other things involved with the process, right? A lot of other things involved. But consider that there is repetition in place here. The number of sticks is variable. So you might start with 7 sticks, and that's what it does here. But it won't always be 7. It could be 15 or 20 or 100, right? That would be a very long game, but it is what it is. So with that in mind, consider whether or not it's possible to know how many turns it's going to take to win or lose this game, right? And use that to help you decide what kind of repetition might be the best form to use here. The other thing that I think you should keep in mind is that 1 turn, right, means that either the human goes or the computer goes. And I think that it's important to make the distinction that, that is what a turn is. 1 turn is not the human and the computer moving. 1 turn is either the human goes or the computer goes. And I would really strongly recommend that as you're writing your code, you make it mimic that such that 1 turn, 1 trip through your repetition is actually 1 turn. Either the human goes or the computer goes, but not both, right? Because we'll take care of the next person on the next turn. The other thing to keep in mind here is that it's possible to cheat. So if I'm the human and I see there's 10 sticks left, I could type in 10 to try and be clever. And we want you to check against that. So you're going to have to think about what you might need to do that. And again, I would ask you to consider, is there a number of times that person could enter in a wrong value? Like they could enter in the wrong value once and you could catch them and say, enter another one. Please, do it right this time. But does that mean they have to do it right the second time? Or the third time? Or any time? Right? Your code should be prepared for your users to be stubborn, perhaps. So just keep that in mind as you go. But try to also not get too overwhelmed by what we're asking you to do, right? You'll notice that as I was working through the first problem, which was the larger problem of the 2 that I did today, I did it piece by piece. I didn't sit down and just crank out the whole thing in one go. I very deliberately wrote a little bit of code, tested it to make sure that it worked in the way that I thought it would, and then wrote a little bit more code and tested it. So try and be very deliberate about that process and just pick off little pieces at a time. You don't just have to magically spit out the whole thing all at once. Pick the low-hanging fruit, just get that ball rolling, and I think you'll find that getting started, can be the hardest part. And once you get that code flowing, sometimes it's not as bad as you might think it will be. I hope you have fun with this assignment. It's a great one. And as always, if you have any questions, I hope that you set up an appointment to come and see me in office hours, or come in and see me during the review sessions that we have every Tuesday in McDonald 162. That's going to do it for today, though. I hope you all have a great weekend, and I'll see you in class next week.